Welcome to the Masters of Engineering podcast, episode 32. Now, today we're going to be talking about farming robotics, open source farming robotics. My guest today is Rory Aronson. He's the CEO and founder of FarmBot, and we've got a lot of interesting things to talk about. Rory, welcome to the podcast.
Thank you for having me, John. It's such an
Mhm.
honor to be here because I've been using SolidWorks and then Onshape for the majority of my life. So this is really cool.
Can you tell everyone what is FarmBot? What do you do? What's your mission?
Yeah, so FarmBot is basically like a big 3D printer for your garden. So picture a three-axis CNC machine, X, Y, and Z coordinates. It moves left, right, forward, back, up, and down. But instead of extruding plastic, it's going to plant seeds in the soil. It's going to water. It's going to take photos to monitor your plants, to find weeds. It's got a built in weed whacker. So you've got this three-axis machine. It's all controlled by an Arduino and a Raspberry Pi. It's connected to the internet. And you can essentially program your garden and sort of set it on autopilot. And all the hardware is designed to be weather resistant, so it can be outdoors in a greenhouse on an urban rooftop. And we actually also have a lot of educational customers who use the FarmBot as a teaching aid.
Really, really fantastic that you're doing this. And so, what led you to starting to work on this? What got
Yeah,
you into it?
so
You were early in your career, to say the least, right?
yeah,
Yeah.
when I was in college, I started growing a garden in the backyard and, doing it the old-fashioned way. You put the seeds in the ground by hand, you go out there every day, pull some weeds, spray some water with the hose. And then I started separately working with 3D printers, with laser cutters. I helped found a maker space in my town and got really into that type of maker technology, CNC equipment. And I thought to myself, "Hey, where's the 3D printer? Where's the laser cutter for the garden?"
Mhm.
And I thought, "Surely this must exist. Surely there must be a way for there to be kind of a hobby level piece of equipment that I can set up, maybe on some rails or something like that over a raised bed and be able to set the garden on autopilot and have it do things a little smarter and better than me, and also be able to do those things while I'm busy, while I'm studying, while I'm out of town for the weekend, while I'm busy doing other hobbies." And to my surprise, just, a cursory Google search, I did not find what I was looking for. And so that's where I decided, hey, there's an opportunity here. I was still a student. I wanted to build the FarmBot as my senior project. And I got up in front of the class on the first day of school my senior year, and I pitched FarmBot to my peers, and actually nobody wanted to work on it with me. So for my senior
Oh,
project,
that's
for my senior
terrible.
project, I ended up doing something completely different, and I really didn't start working on FarmBot until after I graduated. So that summer, I basically did a second senior project. I wrote up a whole report,
Okay.
following the format of the senior project, where you do kind of these design explorations, you develop a bill of materials, you do some testing of some type, you make an initial design, and then you build a prototype. So actually, that prototype is right behind me right here,
Oh,
hanging on the wall. So it's let's
oh
see if I can
wow.
do it the right way. So
Yeah.
that is the original gantry. It's
Okay.
actually an old bed frame that I chopped up and re-welded back together. And
That's
on
cool.
the sides there, the little white things are the wheels from a garage door. So I went down to the hardware store and got some of those, and
Ah,
then that's just a trowel. And this was just honestly, it was more of a visual prototype than anything. It didn't have any electronics or stepper motors, anything like that. It was more of kind of a visual aid, and it was kind of based off of this initial design that I had in SolidWorks, and then in my kind of second senior project report. And that report, I refer to it now as a white paper. I published that online, and I said, "Hey, I'm looking for people to help me build this. I'm a mechanical engineer. I can bring sort of that expertise, but I'm going to need people who know how to write software, other people who are interested and excited about having, a 3D printer for your garden. Um, and in publishing this paper online, I made a point of making all of FarmBot open source. So all of the kind of the work that I
Yeah.
had done was now available online for free. And so we were just basically, unincorporated, just uh, working from our garages basically for a couple years. And then when we felt we were ready to launch the product to the public in a way that, hey, we're going to want to sell kits to people, that's when we formed a for profit company, but
Mhm.
specifically a public benefit corporation. So, in addition to profit, the company also exists to pursue these public benefit purposes. And our public benefit
Mm.
purposes are to release all of our designs open source for the community. And that really goes back to kind of an ethos around food. So, of all the things in the world that people might need, there's a couple essentials, and food is one of them. And 100 years ago, 200 years ago, since the dawn of agriculture, if a farmer was successful in their community, that was success for everyone. And farmers would work together and they would share seeds, they'd share tools. And this still happens today, of course. But I think a lot of technology specifically has become isolated and siloed and patented, and in the ag tech space, I wanted to be a bit of a harkening back to the way things were, with a
Mhm.
modern twist. So that comes in the form of making these sort of high-tech machines, but they're open source. They are completely free for everyone to download the CAD models, look at the software source code, make modifications. They truly own the technology through and through. And people
Yeah.
can actually build their own farm bot themselves if they want. It's a lot of work, but
Yeah.
all the stuff is there for them to be able to do that. And that's part of that sort of
It's really cool.
sharing of the tech.
I have to say, I've seen a lot of startups and corporations. I've been around entrepreneurship my whole career, and I just never heard of a public benefit corporation. It's such an interesting thing. Do you think that being open source has done obviously it's been good for the community to put the IP out there. I'm sure not only do people build the machines, but people probably reference them and are inspired by them for building things other than farming robotics. And that's so thank you for doing it on behalf of everyone. But are there other benefits? Like, do you think that your design has improved because you make it open source?
Absolutely. Most software is built with open source technologies, and uh, that is maybe the shining example. Open source
Yeah.
libraries in software where the community can come together and build something better. They can find bugs, they can report issues, they can collaboratively uh, fix problems and build features, and that also transfers over in a little bit lesser of a degree, but it does transfer over to hardware as well. So we have, I'd say, four main pillars of product. We have our kind of hardware, we have the software, we have the data that kind of powers the farm bot and gives it the knowledge of what to do, how to take care of a plant, and then we have our documentation. And
Yeah.
all 4 of those pillars are open source. You can edit our documentation or, read the source code that
Cool.
powers it. You can,
Yeah.
um, fork the CAD model and 3D print your own parts. You can run the software on your own server, on premise and edit however you want. And so each of those pillars is open source, and there's different ways in which community members can contribute to those, and make an impact. I would say the tooling and the community is most used to that when it comes to software,
Mhm.
but we have seen contributions from people on the hardware side, on the documentation side, on the data side, where domain experts can come in, or people experience a certain problem can come in and provide a fix or a new feature.
Do you think more hardware should be open sourced? It would be good for the hardware developer.
I think it should. I think people are maybe unnecessarily scared of people ripping them off, or a
Mhm.
competitor taking their IP. What I would say though is that if somebody is going to take your idea and build their own company with it, or spin up a knockoff, they're probably going to do that irregardless of what kind of protections or not you have in place. um, it's quite easy to buy a product and kind of reverse engineer it and look at it, if it's not an overly complex product at least. And I would say that the benefit of releasing stuff more openly and transparently is just builds a lot of goodwill with your community, with your customer base, and it's a great marketing opportunity. People are attracted to that aspect of your product. They say, "Oh wow, if this breaks, I have the right to repair it. I can actually maybe even repair it myself using the 3D printer I have in my garage, or uh, maybe I have a little home machine shop," and that's exciting.
Yeah.
That they're empowered to do those things. And if it's all locked down and private and protected, you kind of shut down that opportunity for people to make modifications. Not that they can't, but it's a little bit more difficult to do so. And yeah, I think if
Yeah.
more hardware was open source, we'd see just more people excited about it, and more people tinkering and doing interesting things.
It's a great message for people to hear. Can you tell me a little more about your CAD journey? What age did you start using CAD, and about the journey with CAD at FarmBot?
Yeah, so my dad is a mechanical engineer. So I grew up tinkering, playing with Legos and Kinects and Rock and Bach. And then once I had a computer, uh, I pretty quickly got SolidWorks on there. That was, I don't know, 25 years ago. And that was the tool that my dad was always using. And so I wanted to be able to use it as well, to tinker around and design little sort of ideas in the computer. And so I really started at a young age. I was probably, I don't know, 7 or 8, using
Yeah,
SolidWorks.
that's pretty young. I've seen a lot of CAD users. That's pretty young. So,
Yeah, and I don't know if I was developing anything amazing at that time, but it was, sowing the seeds of being able to have a career using a CAD tool like SolidWorks, or eventually Onshape, for a lot of the work I do. Um, so I feel very at home in a CAD environment. It's very familiar to me. When I'm describing things, I'm almost visualizing it, spinning it around in CAD,
mhm.
and I can. It's very intuitive to me of how to go from an idea to a CAD model to a manufacturing production line, because of that early use.
And so when you started FarmBot, you first modeled in SolidWorks, is that right?
Yeah, so I use SolidWorks in school as well, in university, to do all of
Mhm,
mechanical engineering homework and stuff. And at that time, Onshape did not even exist, or maybe it did, but it was in stealth. It was still being built out in private.
mhm.
And when I started FarmBot, I naturally just was using SolidWorks because that was the tool of choice at the time. Uh, to be honest, though, SolidWorks for FarmBot always felt like a hindrance, because I had ambitions to share FarmBot's CAD models online for free. And with SolidWorks, you can put up the part files, but for somebody else to use those, they're going to need to have a license of SolidWorks,
Yeah.
and they're basically going to have to be a professional engineer in some capacity, or maybe a student, to be able to truly access and use the source CAD models. And then you can also export everything to open format, like a .stl or .step, but then you're gonna lose the design intent. You're gonna lose the feature tree, and you're exporting in a one way, and then it can't really be brought back. And
Mhm.
that's great for 3D printing or whatever, but it's not really giving people the source files. So as soon as I saw and heard about Onshape, it was still in beta, and I thought that's the tool for me. So I'm an early adopter of technology. I ended up making the switch. I actually have a blog post about this on the FarmBot blog about switching to Onshape. I said this is the future. This is like Google Docs for CAD. You go from having to export and save files and emailing them to somebody to no, here, just use the tool. Just use the
Yeah,
thing that it was originally made in,
yeah.
and it's collaborative and you can share. And it for a project like FarmBot where I'm trying to share these files with thousands of people, people that I am actually not even in contact with, that was, exactly what I needed at the time. So it was very early. I spent, a couple weeks probably redesigning and kind of rebuilding every single part file for the FarmBot, recreating it in Onshape using kind of the Onshape best practices. So I spent a lot of time learning,
Mhm.
reading through the documentation. Um, and I mean, not only do you get these sort of features where you can share stuff online and people don't need to download an app, they can just open it up in their web browser. And you can not only is the sharing so good, but Onshape really pioneered a lot of new paradigms for like the mating and the way stuff
Yeah.
works at the
Thank
tool
you.
itself, and boy,
Yeah.
is it is it a lot better. Once
Thank
I
you.
once I
That's
made the switch, I really did not wanna go back, even though SolidWorks has a special place because I that was the first CAD tool I really used. Um,
Yep.
Absolutely love Onshape. So, yeah, I redesigned everything, and then from there, there was no looking back. So every new version of the FarmBot was done natively in Onshape, and no longer was I spending the time exporting files and sending it to people or having to manage the project in that way. It was all just always available, the most up-to-date version available to anyone, anywhere, whether it's one of my manufacturing partners or uh, myself that I'm just trying to get a file for 3D printing, or somebody who's contributing to the project, or just a random passerby who heard about FarmBot on the internet and maybe popped in and looked at stuff for a little bit, and maybe that inspired their own project in some way.
That's great. Great story, and thanks so much for being an Onshape fan, and I love hearing it, and all the things you're saying are things we had hoped to hear, and so it makes us happy. What are some of the biggest challenges you had in developing the product, scaling it, introducing new variants to the product? What are some of the biggest problems you had to overcome
Yeah,
in the
so
design?
I would say FarmBot is not a simple product.
Yeah.
We have over 100 unique components within the kit. There's over 1,000 parts in total in a fully completed FarmBot.
Yeah.
There's a lot of unique injection molded components. There's circuit boards. There's cabling and um, these. Everything has to be weatherproof and be able to withstand staying outside in the snow or the kind of extreme heat of summer. So there's a lot of considerations that have to go into it, and kind of managing all of that and not succumbing to the complexity has been a challenge. So in recent
Mm,
years and iterations, a lot of the focus on the design has been trying to eliminate complexity. So maintaining the feature set, but making it simpler and more elegant is really where we spend a lot of
mm.
time.
Hey, you have a lot of customer stories. Can you tell me a favorite, like if a favorite or recent or notable customer impact, a story of someone using FarmBot? What are some of your favorites as the
Yeah,
creator?
absolutely. I'd say my favorite is there's an organization up in the San Francisco Bay Area, and they are looking at doing coral reef restoration. So
Oh,
typically, coral plants are grown in kind of a greenhouse type environment in these big water tanks, and it's
Uh-huh.
quite expensive. It's very labor intensive, and it's really only done for the purpose of selling coral plants to hobbyist aquarium owners. Um,
Oh.
so people are willing to
Mm,
spend, anywhere from 10 to hundreds of dollars on a unique coral plant for their aquarium.
mm,
But that's much, much too expensive for doing some type of restoration work where you would, let's say, want to plant thousands or tens of thousands of coral plants in the ocean. So what this organization is doing is they're looking at, well, how can we automate the production of coral in a greenhouse type environment, and then you later transplant that into the ocean. And they were looking up information online, trying to find, are there any kind of three-axis CNC machines for growing things? And they came across FarmBot, and FarmBot is very much designed for growing in soil, on your typical
yeah.
garden bed. But they said, "Oh, we can take this and look at this. It's open source. We can adapt this to growing coral plants." And there's, like I mentioned earlier, there's affordances within the design
Mm,
that are conducive to making those types of modifications. So what they did is they took a stock farm bot, they mounted it over a water tank, and instead of using the tool head that comes with the farm bot, they basically added their own attachments to the z-axis.
mm,
So they have a
yeah.
coral scrubbing tool. It's like a toothbrush that rotates more or less, um,
Oh,
and
cool.
a
Yeah.
special camera with sort of a plastic dome on the bottom that they're able to submerge it underwater to take a photo just under the water surface of the coral plant so that they can identify diseases and um, sort of algae growth on the coral that you don't want. And then they even went another step further. They have a way to pick up the coral plant. It's grown on some type of substrate, and they have a way of picking up the entire pod. And the farm bot will bring it over to a station kind of at the end of the water tank
Oh,
and allow a human to inspect it or maybe remove it or add a new coral part to it. And then the farm bot will take it and put it back into the water, at the exact same location. So they really went, you know, pretty far in making modifications, and certainly not for the average home user to make use of, but for this kind of scientific noble endeavor of, hey, how can we replant the oceans with new coral? It was a really cool application of the FarmBot and especially the open source aspect.
Roy, well, that is such a cool story. I never would have imagined that FarmBot is being used to restore the ocean's coral reefs. So I just want to thank you so much for taking the time to join us today. Rory, from to our listeners, I mean, how cool is it to hear that from, it sounds like Rory and FarmBot, you've made an impact on everyone from hobbyists who want to grow some vegetables in their garden and are a little lazy about doing it to restoring the ocean's coral reefs. Amazing spectrum. I'm sure there's many other cases. I want to also say, Rory, is it correct that if they want to learn more, they can go to your website, which I know has other customer stories? Is it farm.bot? Is that
Yep,
correct?
that's it.
Farm.
Farm.bot.
So FARM dot, it's dot B-O-T, right?
Yep.
FARM dot B-O-T. Roy, again, big thank you. Big thank you to our listeners for tuning in. And Roy, what an amazing story. I mean, a lot of people have ideas in college. Very few people can sit there years later and say they went out and did it. I think your story is a story of action and persistence and now impact that I hope you're proud of. And I have a feeling we're going to be seeing a lot more farm bots in the future. So thank you
Awesome.
so much
Thanks,
for
John.
talking today. That's it for today. See you all next time on Masters of Engineering.